do this. Okay, so I'm going to go through lesson 41. I'm going to go through this quickly, and then I'm going to give you the last little bit to finish off some more stuff on the style, you know, get some more of it done. And I might unlock the next thing for you guys to work on too, but I'm going to explain what I want you to do. First things first though, before I jump in and do the same thing I always do, can you guys see a big sign that says lesson 41?
Yes, sir.
Yep, good. All right. So, lesson 41. We will learn about how precipitation reaction makes solids. So, there's a bit of a weird learning goal, but I thought, well, that's basically what we're doing, so let's do it. Going back for a second, just to look at what we did last time. Last time that we had class, what we did was we looked at types of reactions. So we talked about these four. We talked about combination, which is when things come together. Two individual things come together to make one. We talked about decomposition, when one thing breaks up into two small parts. We talked about single displacement. So this is when something comes in and takes another person's partner. We used the analogy last time as like, a bro comes in and steals another guy's girl, and then the other loner dude's left off by himself. Whereas the next one, double displacement, is like a swingers party. They trade places. So, for example, in this one, this is a better picture I found afterwards. So A goes to be with D, while C goes to be with B. They swap partners. It's like Wife Swap, the TV show, but only with chemicals. So then after we did that, we did a quick little practice, and then I'll let you guys work on the style. We talked a bit about the Haber process. We said this is a combination reaction. You're starting with two different molecules that are coming together into one molecule. And then that was what was really necessary in order to make fertilizer that was used to feed the world. It did make some dangerous explosives and mustard gas as well. But yeah, it's kind of was like, and we talked a little bit about philosophy, but then I sort of moved on. Now, we're going to talk about what precipitation reactions are. And we're going to talk about, we're not going to go into all of the detail that we want to go to. I just want to give you guys, keep this lesson short and use this as almost like a bit of a taste for what we're going to be doing next week. So that as well, when we talk about next week, I can already assume that you've got some of the basics under control. So let's start off with what is a precipitate? What does precipitation mean? And that's how you say it by the word. It's not precipitation, it's precip. The C actually makes an S sound. So sip, precipitation. I always forget the R, don't ask me why, but yeah, precipitation reaction. Okay, so this is the first thing I'd like you to write down. Precipitation is the formation of a solid from a solution. That's basically what it means. Yeah, all right, yep, I'll give you guys a second to copy this down, then I'll talk a little bit more. So I won't talk while you're writing it down.
Are you sponsored by that coffee brand?
Which one?
The one that you're drinking.
The Dare.
Yeah. Are you sponsored by it?
Yeah, I'm sponsored by Dare Iced Coffee to make this riveting content for you guys.
Crazy.
You know, we've got to watch my language so that I don't get demonetized. Well, actually, I usually watch my language anyway. All right, so I mean, that'll be the day, you know, that'll be the day, like when teachers start to get like sponsors and it's like, you know, we start advertising to students. Actually, that's illegal, I think. I don't think you're legally allowed to advertise. I actually don't know. There's some rules there. I don't think, yeah. I don't think you're allowed to advertise to children in like guerrilla marketing stuff. Whatever, not important. So
what's guerrilla stuff?
Oh, it's
Yeah,
like
I was gonna ask that as well.
I think guerrilla marketing, I'm not too sure about that, but it's where you sort of market something or sell a product using like non-conventional means. So it's like conventional way of marketing something is to make an ad, put an ad in TV or put an ad on the internet or something. Whereas like there are other ways you can market things, so you can be like, it's always worth. It's like guerrilla marketing is the same sort of thing as like guerrilla warfare. It's like, no kind of rules kind of marketing. And I think it's illegal, but I'm not 100% sure. Could be worth looking up. I might look it up later. Okay, so there is another quick terminology for precipitation. Precipitation also means like stuff like rain and snow. And so if you ever hear, sometimes they'll say, oh, the chance of precipitation, which just means the chance of rain, but it can mean any type of rain, snow, hail, anything from the falling from the sky. And although it's not the same word, it has the same similar sort of meaning, right? So precipitation means a solid is formed out of a solution. The idea is the solid forms and it just falls out of the solution. It just kind of like, it just sort of like falls down to the bottom. But, precipitation in the sky, it's like, oh, water randomly forms in the sky and then falls out of the sky. So it's a very similar process. And that's why they've got similar names. So that's what precipitating means. It just means something is being made, something that you can visibly see is being made. Now, this reaction on the right here, this is one of the classic precipitation reactions. This is actually really very photogenic reaction here. This is the formation of lead iodide. And I think I talked about this reaction earlier on. But the formation of lead iodide is you take two colorless solutions, right? This solution here, colorless. This solution here, colorless. But when the two solutions mix, which is right here, it makes a new solid. Now that solid isn't just a solid, it's a bright yellow solid. So it's just like, it kind of looks like, a solid is coming out of nothing. And that's exactly what it is. It's a solid is coming out of nowhere. And that's what a precipitation reaction is. So let's look at what it looks like chemically. Okay, so here we've got a precipitation reaction. Lead nitrate, which is aqueous, goes to which means it's dissolved in water, plus potassium iodine, which is aqueous, which means it's dissolved in water, reacts and makes lead iodine, which is a solid. Now, lead iodide, which is a solid, doesn't stay in solution. Because it's a solid, it sinks down. So this is the lead iodine, it's sinking down. Whereas the potassium nitrate, which is also formed, is soluble. It stays in solution. So it just stays dissolved. The lead iodine no longer stays dissolved. We're going to do three things. First thing, I want you to jot this down. We're going to do three things to this equation. We're going to balance this equation. We're going to, what type of equation is this? And then we're going to do, what is the precipitate? So what's the first step? Who's helping me last time? What is a, let me just pick on someone. You can actually say in chat if you want. Let me pick on someone. Let's pick on Lena. I haven't spoken to Lena in like 2 months. Lena, in chat, if you're listening or you're not playing, Animal Crossing, could I get you to tell me what's the first thing I need to do in order to try and balance this? Or you can say it out loud. Who was it that we caught last time? Lena, what's the first step? See, this is why I can't call on students, because they, don't respond. Let's try. Oh, well, Tina responded. That's someone. Said maybe it sounded like Tina instead of Lena. Doesn't matter. Thank you, Tina. First, yeah, what is the, oh, Tina said balance. Tina, what's the first step though that I'm going to do? What's the very first thing that I usually do when I try and balance an equation?
You look at it.
Yeah, well, I'm looking at it. What do I do first? Label everything. How? Well, the first thing I do is I want to count the amount of ions. So let's do this. Let's do lead, and we'll do lead. And I'm doing this with a mouse now, but it's still pretty bad. How many lead atoms are there? Can I get, yeah, like how many of each? That's what I want. Tina, one last question to you. How many lead atoms are there on the left? Let's see if she, yep, perfect. On the right, I actually asked her 2 more questions. That's actually illegal. How many on the right? 1. Beautiful. Done. Thank you, Tina. I will leave you alone now. So that's lead done. The next thing I was going to do is I would do nitrogen, but I'm not going to do nitrogen because NO3, I can just do nitrate. So I can do that as long as there's the same thing on both sides of the equation. You can just do stuff like that. Who else can I pick on that I haven't heard from a bit? Let's go with, let's try Kevin. Kevin's hasn't got a camera, but he can at least write in chat. Kevin, can you tell me how many, I'm not actually 100% sure Kevin's actually going to respond, but could you tell me how many nitrates there are on the left? All right, how many what? Oh, good, he's listening. Thank you. How many of these NO3 groups are there on the left? Let's see if we can figure this out.
So
Yeah.
I kind of have a question about like.
Hold on 1 second, Brendan. 1 sec. Correct. There are 2. Good job. There are 2 on the left, whereas there's only. Do you know how many are on the right, Kevin? I'll answer your question in a second, Brendan. Sorry, I'm just. Do you know how many nitrates there are on the right-hand side? Kevin, 1. Perfect. Thank you, Kevin. I will stop annoying you now. Now, what was your question, Brendan? Thank you.
You know when you put like numbers before or after like a chemical to multiply it with?
Yeah.
Like the thing. How do you know when to put on the left side or on the right side? Or does it like not matter?
So it does. So I will only try to, if I haven't got, for example, for like, for example, for nitrates, right? I've got 2 nitrates on the left, 1 nitrate on the right. Now, if I want to make more nitrates because I don't want to make more nitrates on the left because then it's going to be 4 or 6. I want to make 2 nitrates on the right. All right, let's pick on someone else. Let's do the potassium for me. Who's going to do the potassium? Let's go with Min. I know Min's here. Min, how many potassiums have I got on the left?
There's 1 potassium on the left.
And on the right?
1.
1. Beautiful. Thank you. And then last but not least, we've got iodine. Brendan, Lee, can you give me the iodines for me? How many iodines have I got on the left and right?
Pretty sure on the left there's 1.
And on the right?
I think 2.
There are 2, yes. So now the next step is to go, well, is everything balanced? 1, 2, 1, 1, 1, 1, 1, 2. So that's not balanced, okay? So I'm going to balance out, the first one I'm going to balance out is going to be probably the nitrates. Because I'm going top down, there's no lead, the lead's balanced, so nitrates are next, and potassium balanced, the 2 metals are done. So nitrates, I've got 2 on the left, I've only got 1 on the right. So should I add a 2? So should I add a 2? This is a general question to everyone. Should I add more nitrates to the left or to the right?
Wait, what? Could you repeat that again?
So I've got 2 nitrates on the left, and I've got 1 nitrate on the right. Where should I add more nitrates?
Left. Oh, wait, no, wrong. Right.
The right.
Right.
Yeah.
Sorry, I read it wrong.
I want to add a 2 here because that's going to bump this up to 2. It's also going to bump the nitrates up to 2. So it's also going to bump the potassiums up to 2, which is a bit unfortunate, but then I'm going to go down the list. Now the potassiums, I've got 1 on the left and 2 on the right. So what am I going to do now?
You're gonna put a 2 in front of the K.
On the
Yeah.
left.
Perfect. That's going to change that to a 2.
Yes, sir. And
it's
now
gonna
you're good.
change- That one's with 2.
Cool.
And then that's going to be 1, 2, 2, 2, 1, 2, 2, 2. Everything's balanced. Perfect. So now that's the first question done, is to balance this. And yeah, the only times that it gets really challenging, and usually most of them will be like that. The only times it gets really challenging is when you start to get like lots of oxygens and stuff involved. And when you've got that sort of thing happening, it's just what you can do is you can just start to keep building things up and then just adding a 2, adding a 3. It might take you more than one step. Now, who can tell me? Who's someone that hasn't heard from in a while? Maybe we'll go with Alex and Dra. Alex, could you tell me what type of reaction is this? Is this a combination? Is this a single displacement, double displacement, or the other one? The one I always forget the name of the last one.
It's a double displacement reaction.
It is a double displacement. I'm just going to write DD because I can't be bothered writing double displacement. And it's you can tell because then the lead starts with a nitrate, ends with an iodine, whereas the potassium starts with an iodine and ends with a nitrate. We've got a wife swap business going on here. Now, here's the last question. And this question's a little bit challenging, but still, which one of these is we'll throw this over to maybe Elna. Actually, if you're listening, Elna, I would love you to, can you have a guess out of these 2 products? You can write 1 or 2 if you can't be bothered. Which of them is the precipitate? The first one or the second one? That was for Elna if you're listening. Oh, man, I should have asked Matt. I reckon Matt would know. Matt's actually quite cluey. I'll give Elna a minute or 2 just in case she's not aware that I've asked her a question. I'm going to throw this over to Matt. Matt, if you're listening, can you have a guess or write it down? Which one do you think is the precipitate? The first one or the second one? If Matt doesn't get it, I'm just going to tell everyone the answer. Or if Matt doesn't respond. Oh, man. All right, here we go. So the precipitate is lead iodine. Now, can someone tell me why is this guy the precipitate?
Because it's a solid.
It's a solid.
Solid, exactly. If it was, you know, that's how I easily tell that that's the precipitate because it's a solid. Now, and exactly, that's what a precipitate does. It is a solid that just falls out of the reaction. Are there any questions on what we've done on this slide?
So what's an aqueous again? Or
aqueous means it's dissolved in water. So,
wait, so because then I thought of it as like aqua, so I kind of got confused between that and liquids.
Yeah. So, okay. So a liquid is a liquid. So, whereas aqueous isn't a liquid. It just means that thing is dissolved in water. So if you didn't have water, then it would just be solid potassium iodine. How I guess I sometimes think about it is like water is a liquid, okay? Because if I took some like iron and I melted it, I could make it into a liquid. But if I took some, and here's one that's weird, if I took sugar, I could heat sugar up and I could melt it. So you could have liquid sugar. Or I could take a lump of sugar and add it to water, and that would give me dissolved sugar or aqueous sugar. Yeah, you can get liquid sugar. It's kind of weird. It's more of a syrup sort of thing. It's called, isn't that called Coke? Yeah, pretty much. Liquid, but even then, Coke is just a very highly concentrated aqueous solution of sugar. But yeah, you can get liquid, and yeah, so that's the difference, is that a liquid is just something that's being melted down to become a liquid, whereas aqueous is something that is being dissolved into water.
So an aqueous isn't like a state, because I thought like the three states were solid, gas, and liquid. So then aqueous is just like a solution between like.
Yeah, exactly.
Yeah.
Aqueous is not a. You're right. You're right on the money there, Brendan. Aqueous is not a state. We call it a state in chemistry, but it's not a physical like state of matter, like solids and liquids and gases. It's just like it's a temporary state. It's like a change state. It's a bit different, but yeah, that's how we refer to them as.
I see.
Yo, I got a question, Mr. Greer.
Yep, sure.
So, let's just say I went out and I bought Coke, yeah?
Yep.
And you know how it has sugar and all that shit swimming around it? Does sugar settle at the bottom?
No, good question. No, it doesn't. So because the sugar is dissolved in the liquid, and this is something that I teach a lot more in year 9, but it's fine. It's really important for you to understand is because it's dissolved in the solution. What that means is that because it's dissolved in the liquid, it makes a solution. Now, what dissolved means is that the molecules of sugar are evenly spaced throughout the whole liquid. What that means is if you took if you had like a vat, it's like 10,000 liters, and you took a shot glass of liquid from the very, very top, and you took a shot glass of liquid from the very, very bottom, if sugar is properly dissolved, then they should be the same concentration of sugar. Okay, it just means it's evenly spaced out. That's what dissolved means. Okay, however, you could get something like a precipitate, and you could get something like a suspension. Now, a suspension, this middle one here, is when you have a precipitate that's sitting in a liquid. And as time goes on, it will sink to the bottom. What that means is that you sometimes have a higher concentration at the bottom than the top. Sometimes you will notice that, and you might be thinking, for example, I have cups of tea every so often because I like tea. And if I make tea, I'll add 1 sugar to it. But sometimes, because I don't stir it very well, some of the sugar gets dissolved, but because I don't stir it enough, a lot of the sugar just sinks to the bottom. And that's just because I haven't stirred it around enough to get it to dissolve properly. Yeah, the thing about Coke is that if you left a bottle of Coke sitting on your windowsill for 100 years, it wouldn't sink to the bottom. You wouldn't come back 100 years later and see a bunch of sugar in the bottom and stuff. But if you left something that has got stuff not dissolved in it, just floating in it, like orange juice, if you came back in 100 years, all of the pulp will have sunk to the bottom of the orange juice, and you'll be left with like a clear orange sort of liquid on the top. Does that answer your question, or have I kind of gone off topic?
Yeah, thank you.
Good. Okay. So, any other questions? Sorry, are there any other questions on? Someone's got a question, or I don't know. Maybe it's Talik. It's like, how about like alcohol? Well, good question. Alcohol, Talik, is similar sort of thing. Alcohol. I don't, when you say like alcohol, I don't know what you could be asking two questions here. So, and because I'm like, I have to admit, I know that you guys, this is annoying because you guys have hit me right in my tangent zone and I'm trying to resist it, but I'm going to go anyway. Alcohol, you can dissolve alcohol in water, right? Alcohol, now you can dissolve alcohol in water and that will make an alcoholic beverage, for example. And that's why when you see on the back of labels, it says, oh, this alcoholic beverage, this wine is 10%. That means that 10% of the weight of it is dissolved alcohol. So you can have dissolved alcohol and stuff like that in water. And it actually, and yeah, that's what makes alcohol. And the greater the alcohol concentration, so you can have like in spirits, you can get up to 20% alcohol dissolved. You can get all the way up to about, I think 80%, 70% to 80% in absinthe is just like alcohol, not only a tiny bit of water.
Oh, what
So
the
yeah,
flip?
it's kind of, yeah, it's kind of intense.
Yeah.
There is though, the interesting thing is you can get alcohol as just a liquid. You can get pure alcohol, which is pretty much what, as someone said, which Salik is saying, is hand sanitizer. And that's exactly what it is. It's pure alcohol. However, because they can still dissolve things in pure alcohol, so what they dissolve is they dissolve something called a denaturant. The idea of the denaturant is that it makes you incredibly sick. So you can't actually get drunk from drinking hand sanitizer because what you end up doing is you drink this denaturant and then it makes you vomit like pretty much instantaneously. So the school initially was at Braver College was really worried about giving students like access to alcohol-based hand sanitizer because they're like, oh, what if the kids steal it and drink it? Like, well, they can
What
try.
the flip?
but-
Who would drink hand
What the
sanitizer?
fuck?
Hand sanitizer.
That's ghetto alcohol, bro.
So if
Some
we
of
wanted
the-
to drink it, we'll just go to our cupboard.
I know.
Exactly. Some of the
What the
some of
fuck?
the
Who would
higher
drink hand sanitizer,
some of the
bro?
leadership in the school were like, that was their concern, and I was like,
That's the stupidest thing ever.
I'm like,
We have
I
some
don't
dumb
think
leaders.
I'm
don't
sorry,
think-
Sue.
students are that desperate. I mean, don't get me wrong. They probably wouldn't like if you offered them free alcohol, they would take it. But I don't think they're that desperate to drink hand sanitizer. So yeah.
What the heck?
The other thing about hand sanitizer is though it has got stuff dissolved in it. So, and you can and that's the cool thing about alcohol and other liquids is that you can dissolve. Like water isn't the only thing that dissolves things. You can dissolve things in alcohol. That's why you can dissolve certain gel in alcohol to get different hand sanitizer things. You can also dissolve perfume and stuff into alcohol, and that's how you end up with like sweet stuff.
What the heck?
So yeah, but yeah, don't drink. Yeah, I would not drink excessive amount. Listen, if you're at the point where you're drinking, if you like, I want to get drunk so badly, you should just that I'm going to drink hand sanitizer. You should find something else to do with your life. I'm going to finish off this lesson. I've got a couple of slides left and we've got like 4 minutes left. So we're going to wrap this up at the very end and then we're going to, and then I'm going to unlock the other style thing. So let's just wrap this up. So precipitate in a solution. Now, what does it actually look like? So just finishing this off. Precipitating the solution can make the solution look cloudy. Hence why I said, oh, like orange juice. Orange juice actually looks cloudy. You can't see through it very well. It may form a suspension. Now, a suspension is when it may form a suspension when it forms and stays floating in solution. So what that means is that I've completely stuffed up this sentence here. Sorry about that. The idea is that the suspension, the solid particles stay floating in there, kind of like a little bit more like milk. So the milk is like, milk doesn't settle. It just has these floating solid particles that never sink. always float. But usually what will happen is that a precipitate will sink to the bottom. So usually over time, this precipitate here will sink to the bottom. And you just get a white powder at the bottom, and that's called a precipitate. The solution is apparently called a supernate. I have never heard that term used before, so I don't expect you to memorize that. But yeah, just in general, just be aware that as time goes on, the suspension, it will form and stay. The precipitate in the solution can make the solution cloudy. As it forms, it'll sink. I'm going to change the slide now because I haven't got that much time left. I've got 2 more slides, but I don't think I've got much on the other 2 slides. Not, at least not, yeah, these are the last 2 slides. So once we get through those, we'll be done. So it's a little bit, we might have to go a little bit past 306, but it won't take too much time. This is a bit of a teaser for the next lesson. So this is where we're going with this information. The next lesson, we've got to talk a lot about this new term, but we'll get to that in a second. We've got 2 reactions here. Ag is silver. So we've got silver nitrate plus sodium chloride makes silver chloride plus sodium nitrate. Okay. The other one is potassium nitrate. And you look at, all I've done in this one is I replaced Ag with K. NaCl, NaCl, Ag with K. NaNO3, NaNO3. These reactions are similar, but only the top one is a precipitation reaction. Can you guys tell me why is this bottom one not a precipitation reaction?
Because they're all fucking aqua stuff.
That's what I was gonna say.
There ain't no solids. There's nothing. They're all liquid
There is no
stuff.
solids in it.
There's no solid, exactly.
Yes, sir.
They're all aqueous, so therefore that means that there is no solid that's formed. These will be colorless solutions, and afterwards they'll be colorless solutions. But here's the question, and this is the teaser for the next lesson. We'd like you to copy this down, and then I'm going to change to the very last slide. What is it that makes this a solid, but this one not a solid?
Because it's logic. We see an F in there.
Yeah, but why? If I gave, why is KCl not a solid? Like, what makes it different?
Would it be because one's a single displacement thingamajiggy?
No,
Yeah.
because both of these are double displacements. The Ag goes to the AgCl, the Na, so they're both double displacements.
Is it because, does it depend on the one? Oh, never mind. Never mind. I'm gonna say it.
Does it depend on which molecules bond together?
Yes, it does.
Dang it! Frick! I was actually gonna.
I know you were, Alethea. That's why I'm like,
I was gonna be
"She's
like
gonna
the one
say this?
before.
Because she's going to be right. And then you
I didn't want to say it though.
You didn't want to be wrong, and I know, and that's one of the things I hate about students is like, oh, I don't want to be wrong, so I don't want to guess. It depends on what it's bonded to. Silver, and I think it's like, we're going to have to talk about these later on, but silver salts, so silver chloride, silver iodine, they're solids. Same with potassium carbonate, that's a solid, but potassium chloride, that's soluble, that's easy. So it's because it's a silver, that's why. So this brings us to our very last slide. If you haven't got this slide copied down, remember these slides are still available on the classroom. You should be able to download them. But the last slide is this here, and this is a bit of a hint for next lesson. Solubility is what we're going to be talking about. AgCl is not soluble in water. That means it doesn't dissolve in water. So AgCl just can't dissolve in water, and some things won't dissolve in water. When you think about this, there are lots of things that don't dissolve in water. Glass doesn't dissolve in water, dirt doesn't dissolve in water, plastic doesn't dissolve in water. There are a lot of things that don't dissolve in water, which is really good because we don't want everything that goes into water to suddenly disappear. when you make AgCl, because AgCl doesn't dissolve in water, when you make it, it has to be a solid. The difference is KCl is soluble in water, so no solid is made. Instead, it just dissolves in the water, and then that's it. So, yeah, that brings us to, once you got that topic down, you guys can end the lesson. Yeah, if you like this lesson, please like, subscribe, ring the bell icon, and I.
Oh Jesus! What the
I
heck?
did.
What the heck?
The next lesson
I don't
is.
think I'm gonna subscribe.
Yeah, nah.
We'd
Just
like
like,
to thank our sponsor. You know, who's the sponsor going to be? Rage, Shadow Legends, whatever.
oh shit!
Uh-uh.
No, no.
You
No.
gotta watch those, and you gotta ask yourself,
Don't.
who is playing this game? Like World of Battleships, and like looking at it, like who's playing these games? Oh. Anyway, guys, you guys have a great weekend. I will see you guys Wednesday.
Oh.
Yeah, we'll go through solubility next time. Okay,
Okay.
take
Yeah,
care.
cool. See ya, Mr. Greer.